those hyperbolas instead of the graph. So if you have that note sheet from yesterday that has the chart on it that we went over, that'll be helpful to you as we go through this. So that chart we went over yesterday in class, you can have that out. So again, we're writing equations of hyperbolas. So in example 1, we have vertices at 6, 0 and negative 6, 0, and a foci point at 8, 0 and negative 8, 0. Okay, so my first step here is to decide if this is vertical or horizontal. Okay, so I look at my vertices for this. Okay, and I see which value changes. Okay, so if your value changes in the x position, it's horizontal because you have a negative 6 and a positive 6, so that stretches along that x-axis. So it is horizontal. Okay, and I do have 4 steps to solve this. Okay, so make sure you have enough room for those steps. So first step, after finding which way it goes, just like yesterday, we're going to find the center. Okay, so to find the center, this one's a little bit easier because it's going to be at 0, 0. But if you're not given points like this, you can just use the midpoint of your vertices. Okay, so we want to use the midpoint. Of the vertices. So that means I'm going to average my x's and average my y's. Okay, so add your 2 x values together, which is 6 and negative 6, and add your 2 y's together, which is 0 and 0, and divide them by 2. So when I have 6 plus negative 6, that is just 0 over 2, which is 0. And 0 plus 0 over 2 is still going to be 0. Okay, so our center is at 0, 0, and that is your h and k value. Okay, so we're still finding h, k, and we're still finding a and b to plug into that equation. So next step I want to do is find a. So step 2 is to find a. Okay, and we want to use one of our vertices to do that. Okay, so if I look at my chart from yesterday, since we're using a horizontal hyperbola, okay, my vertices are at h plus or minus a for that x value. So I have to set the x value in one of my vertices equal to h plus or minus a to solve for a. Okay, so it doesn't matter which one you choose, negative 6 or positive 6. I'll just use positive 6. That has to equal your h plus or minus your a value. Now I already found what h is, so I can plug that value in for h. So we have 6 is equal to 0 plus or minus a. Okay, if I add 0 to a, I just get a. So I'll end up with 6 is equal to a, and just like before, your a and b values should be positive. Okay, those a and b values should be positive. Okay, so now I have h, k, and a. Now I need to find b. However, I'm given the foci points, not the co-vertices. Okay, so I have to use those foci points to find c in order to find b. Okay, so that'll be step 3. Okay, so we're finding c to find b. Okay, and we're going to use a foci point. So when you're given a foci point, you have to use C to find that point. So again, if you look at that chart, for a horizontal hyperbola, our foci point, our x value for that is at h plus or minus c. So you need to take your x value from one of your foci points and set it equal to that section. Okay, so an x value from our foci point would be 8 or negative 8. Okay, I'm just going to choose the positive one, but it doesn't matter which. So I have 8 is equal to our h value plus or minus our c. Okay, and again, I know what h is from our center. So h is 0, so I would plug 0 in there. And again, since I'm adding 0 onto c, I do still end up with c. So c will be equal to 8. Now we did this in order to find out what b is. Because once I have a and c, I can use that formula from yesterday, which was c squared is equal to a squared plus b squared to solve for our b value. Okay, so c squared is equal to a squared plus b squared. Okay, so I would plug in my c value here. So I have 8 squared is 64. A value is 6, so 6 squared is 36. And that's plus b squared. So subtract 36 from both sides to get 28 is equal to b squared. And then to get b, we just take the square root of both sides. So I have the square root of 28 is equal to b, and I want to leave it as a square root. Okay, remember when you're writing out an equation of a hyperbola, that a and b value are going to be squared at the end anyways. So when you take the square of a square root, it'll just cancel, and then you'll have a whole number in that denominator instead of a decimal. Okay, so leave it as that square root. Okay, so now that I have h, k, a, and b, I can plug it into that formula. So for a horizontal hyperbola, we have x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So I just need to plug my values into that equation. So I can write this as x minus 0 squared, since h is 0, over our a squared value, so a was 6, so square 6 to get 36, minus y minus k was 0, that quantity squared, over our b squared value, so squaring that square root just leaves us with 28, and then that has to equal 1. Okay, so I can write it like that, or remember if I have an x minus 0 squared, you can write it as x squared over that 36 minus y squared over 28 is equal to 1. Okay, so either or for that answer there. If it makes more sense to you to leave the zeros in so you don't get messed up with that equation, you can do that too. I won't mark it wrong. Okay, so either or for that answer. Questions on the first one? Okay, can I move on to the second example? Okay, so in number 2, we have the asymptotes this time for a vertical hyperbola. It literally tells us it is vertical. So I don't have to figure out if it is horizontal or vertical. It tells us it is vertical. Okay, and our equation for these asymptotes is y equals 5/3 x and y equals negative 5/3 x. Now recall from that table before, so table yesterday, the slopes of your asymptotes are right here, highlighted. So that means I have a over b in that vertical hyperbola. Okay, vertical slope is a over b. Okay, we're also given the vertices are at 0, 5 and 0, negative 5. Okay, so you can tell this is vertical because your y values change. So first thing I want to do is find the center, just like we did before. So step 1, find the center. We'll use the midpoint of our vertices. So average our x's, so that's 0 plus 0 over 2, and average our y values in those vertices, so we have 5 plus negative 5 over 2. Okay, that will give us a center of 0, 0, and again that is at h and k. Okay, next thing I want to do is find a. So step 2 is to find a. And I am going to use the vertices for this because this could be a reduced slope. It doesn't mean that a is 5. I want to make sure it's not a reduced slope. So using one of my vertices, I will have, since this is vertical, my y value, which is 5, equal to k plus or minus a. Okay, so that gives you your y value in your vertice. So I know what k is, so I can plug in that value for k from our center, which is just 0. Okay, so I will end up with 5 is equal to a. Okay, my next step I want to do is find b. So step 3 is to find b. Since I'm given the equations of the asymptotes, okay, I can solve for b right away. I don't have to find c this time. So you only find c if you're given the foci points. So to find b, we're going to use those asymptotes. So the equation for the asymptote in this vertical hyperbola is y minus k is equal to plus or minus a over b times x minus h. So this is how I'm going to find b. I'm going to use this slope right here. Okay, so I do have a over b, and I know what the a value is in my hyperbola. It's 5. Okay, so since this is 5, and my slope up here is 5/3, okay, I can replace a with 5. So I have 5 over b equals 5/3. So what would b have to be? 3. Because I have my 5's equal in the numerator here, so my denominators also have to be equal. Otherwise, again, like we did yesterday, you can cross multiply if you don't notice that right away. Okay, so b does have to equal 3 there. So now I have the center a and b, so I can write out this equation. Okay, a vertical hyperbola equation is y minus k squared over a squared minus x minus h squared over b squared is equal to 1. And we are just going to replace those values for h, k, a, and b. So we have y minus 0 squared over our a squared value will be 25 minus x minus h, which is 0, that quantity squared, over b squared is 9, and that's equal to 1. So again, you can leave it like this, or we can write it as y squared over 25 minus x squared over 9 equals 1. Okay, so those are your two different answers there. Okay, questions on example 2. All right, we're gonna go to the back then. So all of these examples are a little bit different, and I want to show you each of them. So example 3, we want to write an equation for a hyperbola. Again, we're given our vertices. Okay, since we're given our vertices, we can find A with that, and we can find our center. Now we're also given the conjugate axis for a length of 24 units. Now the conjugate axis is equal to 2b, so that'll help us find b. So looking at my two vertices, deciding whether this is horizontal or vertical, my y values change between my two vertices. So since those y values are different, that makes it vertical because that's a change in your y axis. Okay, so this is a vertical hyperbola. So taking our step 1, finding our center, we need to find the midpoint between our two vertices. Okay, so average those x values, which is 0 and 0, and then average our y values, which is -6 and 6. Okay, 0 divided by 2 is still 0. And then -6 plus 6 is 0, divided by 2 is 0. So our center again is at 0, 0, and that is h and k. Okay, step 2. What's step 2? Find what? A. Okay, so we're finding A, and to do that we'll use one of our vertices. Okay, so I can use 0, 6. Okay, so our y value of 6 has to be equal to the equation for that y value for the vertices in a vertical hyperbola, and that is k plus or minus a. And we know what k is. K is 0, so we plug 0 in for k. So our a value will end up just being 6. Okay, next I want b, since I'm given the conjugate axis. Okay, we're solving for b. So find b and use the conjugate axis. So your conjugate axis is equal to 2b. So we'll have 24 equal to 2b, since 24 is that conjugate axis. Divide by 2 to get b is 12. Okay, so now again I have h, k, a, and b. So we're just plugging it into our vertical hyperbola form. And again that is y minus k squared over a squared minus x minus h squared over b squared is equal to 1. So we'll just replace those values. So we have y minus 0 squared over 36 minus x minus 0 squared over 144. And again, we can just change this to y squared over 36 minus x squared over 144 is equal to 1 as well. Okay, questions on example 3. So it's the same process over and over again. You're finding h and k, you're finding a, and you're finding b. Questions on those first three? I have one more where our center isn't at 0, 0. Okay, so last one. Our center isn't at 0, 0 this time, but we're doing the same thing we did in example 1. Okay, so you're given vertices and you're given a foci point. Okay, so our vertices here, we want to see which values stayed the same and which one changes. So here in my vertices, I have -2 and -2 for my y values. The one that changes are your x's. So you know your x's are the ones changing along that x-axis. Okay, so y's stayed the same, x's change. If your x's change, that is a horizontal hyperbola. Okay, so next we're just doing the same process we did before. So we'll find our center. So we'll average our x's from our two vertices. So we have 6 plus -2 over 2. And then our y's is -2 plus -2 over 2. So 6 minus 2 is 4. 4 divided by 2 is 2. -2 plus a -2 is a -4. Divided by 2 is -2. So this will be our h and k value this time around. Okay, step 2 is to find a. So we'll use one of our vertices, and we need to use the number that changes. Okay, so we don't want to use this -2 here. Okay, because those stay the same. We want one of the numbers that changes. So I'm going to pick 6. Okay, and to get 6, we need to take h plus or minus a. Okay, and again, we know what h is from our center. H is 2. So I need to plug 2 in for h. From here, I want a by itself. So subtract 2. To get 4. And again, this always has to be positive, so a is just going to equal 4. Okay, so again, I'm just using that chart from yesterday to figure out my vertices for a horizontal hyperbola, and your x value changes, so that's h plus or minus a. Okay, next I need b. However, I'm given the foci points in this problem, and the foci points use c to find that value. Okay, so I need to find c first in order to find b, just like we did in example 1. Okay, so step 3, we're going to find c using our two foci. So just like with your vertices, you want to see which value x or y changes. So in these ones, my y value is both -3. So that's not the value I want to use for this equation. I want to use one of the values that change between the two. Okay, I usually pick the positive one. Okay, but you can use -5 as well. Okay, but I'm going to use 9. Okay, and our foci equation for a horizontal is h plus or minus c. So 9 will be equal to h plus or minus c. And again, we know what h is. We know what h is. It is 2 from our center, so we can plug in 2 for h. Subtract 2 from both sides to get 7. So now I know what a and c are. I need to use that to find b. So I need to use the equation c squared is equal to a squared plus b squared. So plugging in 7 for c, we get 49. And 4 for a, we have 16 plus b squared. Subtract 16 from both sides. And then take the square root of both sides to get b is the square root of 33. Again, we want to leave it like that because at the end you're going to square it anyways. Okay, so I now have a, b, h, and k that I can plug into our equation. Okay, for horizontal, we use x first. So we have x minus our h value is 2. Quantity squared. Over our a value is 4. 4 is squared here to get 16. Minus y minus the k value. Since I'm going to have minus a negative, I can just change that to plus 2 right away. That quantity is squared. Over our b squared value will be 33. And that is equal to 1. Okay, questions on writing out equations of hyperbolas?